Alright, hey guys, Vlad here with AVT-Astro. Tonight I've got a special treat for you, and that is comparing about as premium of a scope as you could get to about as entry-level a scope as you can get. So I thought that this would be a fun comparison. I do a little bit of analytics on like the topics that I post and that type of deal, and these type of comparisons are actually usually pretty popular, so I figured this would be a fun one. And the reason that I figured that this one would be an interesting one is because that's an Astro Physics 130 GT. It's about as premium of an APO as you could get. It's 5 inches in aperture. This is about as entry level as a 10-inch Dob as you can get. So essentially, what I wanted to do, first of all, for myself, is just really to see, would a premium scope, even with that severe of an aperture difference, make up, and it's just like raw performance compared to an entry level scope. So anyhow, yeah, let's get to it and let's check it out. All right, so kind of just start with a quick overview of the equipment that we've got going on. So like I said before, this is an Astro Physics 130 GT. If you're not familiar, Astro Physics, they are the best refractors in the world. I mean, there's a few other brands that are, about as good as them, but primarily due to their, rarity, these are considered to be the best. Like, if you wanted to buy one of these brand new, you're out of luck. They're not taking any more orders on these. And the wait line for them is about 8 years usually. So yeah, these are 100% made in America. I think the MSRP on them is like around $8,000 or so, somewhere around there with the accessories. Like I said in the title, so this whole setup, like if you were to buy a brand new, it'd be over $10,000. So about as premium as of a 5-inch setup as it comes. This mount is a Lasmandi G11. My trusty G11, I love this thing. I actually have 2 of them, so that's that bad boy there. In order to make the comparison fair, we are going to be using the same eyepiece, and that is, of course, none other than the Better Zoom. I love that eyepiece. Anyway, so yeah, this is a Coulter. I picked this thing up locally for a couple $100. Like I just had to rescue this thing. And I thought it'd actually be a fun scope just to kind of check out. If you're not familiar with Coulters, these things, they're kind of like, they were made back in the day, like back before 2000 primarily, I think. And they were like as simple of a scope as you could get. Like, this tube is made like out of basically cardboard. The secondary mirror is actually non-adjustable, so you can't really collimate it. The focuser, this is kind of just like an entry level, just basic 1.25 unit, which actually, it's alright. It's decently smooth. I put a red dot finder on it. So yeah, this is like, as entry level as it gets. It doesn't get too much more entry level now. Alright, so anyhow, so right now the planets are not out, so we can't really do a comparison on the planets. The moon is actually out. Probably see her. Yep, she is right there. So I'm gonna start out by doing a quick comparison on the moon. I'm just gonna start out by saying that the 130 GT, that's like the best scope I've ever had on the moon, so I don't expect it to be much of a challenge for the 130 GT to beat out the Coulter. But you never know, right? So yeah, let's start out with that and kind of see how she does. Alright, so just quick update. Basically I kind of took a look. With the Coulter at the 24mm setting with the Better Zoom, and I'll put the magnifications in here what that gives. I'm not sure what they are off the top of my head. The image is not bad, I'd say. It's not great. It's not like really sharp. Like you could never get a crisp focus with it. at the 16 millimeter setting, so that's, you know, about like that mid magnification, it gets, you know, pretty murky. Like, you know, you could definitely tell that it's not in focus very well. And then at the 8 millimeter setting, yeah, it's just, you know, like, you could definitely tell that, you know, basically, I'm not sure if it's just due to the fact that you can't really collimate that scope, or, I mean, the Coulters, they are known for mirrors that aren't that great, so it could be that. I'm not really sure, you know, what's going on. But yeah, I mean, moral of the story is, it's not a really good moon type of telescope, which would also mean that it's not a really good planetary type of telescope. But I'm gonna take a look through the Astro Physics and get back to you on that. Alright, so yeah, kind of taking a look through the Astro Physics. I mean, it's a clear difference, a night and day difference. I mean, I don't care if you've never looked through a telescope before, trust me, you'd be able to see this difference. The atmosphere is actually fairly steady, so it's not really the scene tonight, you know, that's making this huge difference. So yeah, I mean, the clear win would go to the Astro Physics by like a mile. I mean, you know, I wish you were here to take a look. In fact, let me actually try to do eyepiece projection. We'll kind of see if we could see the difference, you know, through the camera. Alrighty then, so here's the 130 GT. You know, we're pointed at the moon, and I've actually finally done a little bit of research. So I'm using the Pro mode on the camera here, or on my cell phone, I should say, my Pro camera. So anyway, I think I'll actually be able to get you guys a little bit of a better view with the eyepiece projection than I normally did. So this is the better zoom at the 8mm setting, 130 GT, you know, just hand holding the camera to the eyepiece. And then I am going to decrease the ISO and hopefully get a reasonably decent view of the moon for you guys. This ISO 50. Yeah, it's looking pretty good. So this is the 8mm setting. Again, I'm not really sure what the magnification is, and I apologize for the shaking. I am not a professional videographer. Oh shoot! Now I lost it. Let me bring this back up. Hey, where's the moon at? Oh, there it is. Okay. So dim it back down. Yeah. So anyway, I'll post the magnification I'm getting with the 130 GT, and then let's try to do the same thing with the Coulter. It's gonna be a little bit harder with that thing because it does not have tracking. This is of course tracking right now. But yeah, let's take a look at the Coulter. Alright, there she is. There's the Coulter. You know, moon's still up there somewhere. There she is. Let me go ahead and point this thing at the moon. Alright, so that should be reasonably close. Gotta readjust my chair here, it's way too high. Alright, so let me make sure it's in there and let me focus this as best I can. Okay, and with the Coulter I could just visually tell it is higher power. So I'm gonna just show you at the 8mm setting. It's about as good a focus I could get, and I'll probably back down the magnification a little bit just so that, you know, we can kind of get more of a fair comparison. So this is the view through the Coulter. Do you see how, like, all the detail is just kind of like, it's almost like a double image, you know? This doesn't, you know, it doesn't really get sharp at all, basically. And it's starting to move out of the field of view. Let me actually, I'm gonna back off the magnification a little bit. I'll probably set it to roughly the 12mm setting. And again, I'll post the magnifications that we're using in the video just so that we kind of have more of a fair comparison magnification wise between the two scopes, because I'm pretty sure that the Coulter has a longer focal length, which will give it a higher magnification with the same eyepiece. So I think this is probably about equivalent, roughly, magnification wise. Alright, so let's take a look now. Okay, so got that, and then we'll back down to ISO. And yeah, so you know, there's a decent amount of detail, but yeah, it's just kind of, you know, it's just not very sharp. It's just kind of like almost like a double image or something like that. And you could see it visually even more clearly than you can on camera. So anyhow, I thought it'd be a cool view for you guys to you know, kind of like actually experience, you know, taking a look through both these guys, know how it compares. On deep sky objects, I'm really not going to be able to do that, but I'll wait for it to actually get dark, and we'll do some deep sky objects and see how they compare. That I think is going to be a way more interesting comparison. Like this one, I wasn't surprised at all that, you know, the 130 GT won. On deep sky, I think it's going to be a lot closer, so I'm kind of curious to see how, you know, this will play out. Alright guys, so now it's getting pretty late. It's already around 10 o'clock, and it's been dark for a while, but I've been waiting for the moon to set to do some deep sky observing. And the first thing I'm going to look at is M42, the Orion Nebula, just to kind of get a good judge on that guy. I'm very familiar with that. I've observed that a lot. And then I'm actually going to, so this book is, or this is actually a photocopy of the book, just because that way, you know, I can kind of write in there and that type of deal. But this is Deep Sky Wonders by Sue Chess. These are actually articles from Sky and Telescope that have kind of been compiled into a book that's divided essentially, like, you know, by a month. I really love this. I highly recommend this book. I mean, I've done, you know, like, so much observing from here, and this is a really good book for visual and actually for EAA. Like, you know, I like doing EAA out of here. I've been working on this book for, I don't know, probably a couple of years, and I still have plenty of articles to go. But anyhow, so the first couple there, you know, I've already done, you know, as you can see, and actually about, 2 years ago with my Takahashi FS 128, and these things I've probably seen pretty, you know, quite a few times. But, you know, this is actually kind of a good spread of objects. There's an open cluster, there's a double star. That's, you know, I mean, that's a pretty wide one, so both scopes should easily split that. I'm actually kind of curious if the Coulter actually will, you know, quite frankly. There's a, you know, a relatively dim planetary nebula in there. And then, you know, there's another triple star Castor, so that's a pretty bright one there. So yeah, between these objects, I think, you know, I'll get a pretty good feel for, you know, how these scopes compare on deep sky. And again, that's included M42. So yeah, let's get out there. Alright guys, so it's nighttime already. You know, it's totally dark. Let's see. So that's Sirius, the really bright one there. Oh yeah, you could kind of see Orion there. So anyhow, I'm going to position the camera right now to where, you know, you could actually see me kind of, you know, taking a look at M42. And then I'm actually going to cut the camera out just because, you know, I'm doing deep sky observing and I want my night vision to be preserved. So I'm not going to have these lights on or anything like that. And then probably the next morning I'll kind of do a recap, you know, of what I thought, you know, as to how both the scopes, you know, perform under the night sky. So I'll see you guys later.
Alright guys, welcome back inside, and that kind of concludes our video. You might be like, wait a second, we haven't concluded anything about these two scopes. In any case, so I guess, the $10,000 question in this case is the premium APO like that much better than, like a $200 Dob? Well, it kind of really depends what you're trying to use it for. If you're primarily into those deep sky objects, like the little small ones that you're going to be using magnifications of 100 times or more on, then a Dob, I mean, like in this case, a 10-inch Dob actually collects 4 times the amount of light as a 5-inch scope. So, I mean, if you think about it, I mean, you cannot defy the laws of physics. Yes, that's about as good of a 5-inch telescope as like you could humanly make, right? So that's cool. It has excellent contrast, excellent sharpness. I mean, it's essentially a perfect 5-inch scope. But guess what? It's still a 5-inch scope. So on deep sky objects, on those dim fuzzies, like I was checking out the Eskimo Nebula, I was checking out M42. The image is obviously brighter on the Dob. I mean, there's really no comparison. Now again, this is a super entry level model, so just because of the fact that you can't collimate it, even on deep sky stuff, the image, just really wasn't sharp, even on those dim fuzzies, so that's kind of a downside. But this is kind of an extreme, comparison in the optical quality. That's actually kind of why I wanted to do that, because if we had a modern 10-inch or like even an 8-inch Dob, I mean, I knew that it'd easily, like do better on the small dim fuzzies. In this case, we have a big aperture difference and actually a big, optical quality difference, or like, build quality difference too. So that kind of, blurs the image. I mean, if I had to choose between these two scopes, right, assuming, let's say they cost the same thing, like say the Astro Physics was on 10 grand, let's say it was 200 bucks. Honestly, I would still go with that by far, because it does have tracking. Everything's just nice and sharp, sharpness wise, everything is spot on. Now, the other thing to point out in regards to deep sky observing is that what APOs are really nice for is those really wide field of views. I mean, with a 5 or a 4-inch APO, I mean, you could get a field of view that's, like 3-4 degrees, across, which is, I mean, huge. They'll fit like pretty much any of the hugest objects, like the North American Nebula. What's the... Should I forget the other nebula in Cygnus, the big old ring one. Oh, the Veil Nebula. It took me like literally a minute to think of the name. I don't know, I just had a brain fart or something. In any case, so the Veil Nebula, APOs are really good for that. The one, kind of like caveat to that is that you do have to be under a dark sky, especially to, to like do those really wide field of views. On most objects, like open star clusters are pretty good from even the light polluted sky, but for especially like nebulas, galaxies, like M31 is another object that really benefits from that wide field of view. I mean, you just really cannot fit that, like, the entire, let's say, galaxy in the field of view of, like, let's say, a 10-inch Dob, to where it'll easily fit in that. And from a dark sky, it's, it's an awesome view to have. So yeah. So kind of sum it up. Dob for small dim fuzzies, it will still be better. I wouldn't really necessarily go like this extreme, in quality down. Like, so if you get a modern, like 10-inch Dob, it will be better than that. Now for double stars, planets, how does that compare? That becomes a lot kind of more, kind of technical. So basically, on most nights I've seen, especially here in the Northwest, like, where I live, a 5 or a 6-inch scope is about the most aperture that will kind of maximize the scene. So having a bigger scope doesn't really give you too much more, because the atmosphere is just not steady enough. Now, if you know that you live in an area that has really good seeing, then yes, maybe a bigger scope will be better for you. I mean, for me, I would hands down easily take a nice APO that's, like around a 5-inch for the planets and double stars. Because on most nights I've seen, I really want to benefit from a, like a bigger scope, and that has the best contrast, best sharpness that you could get out of the scope. It's still pretty manageable in light, and it has tracking too, whereas the Dob would not have tracking. So yeah, that. Okay, to kind of sum it all up and bring the ship home, is the Astro Physics 130 GT worth it over a $200 Dob? Well, that's a little bit like asking if a Rolex, that's 10 grand is worth it more, worth it over like a $10 Timex that you could buy from Walmart. I mean, realistically, the Timex, right? I mean, it'll keep the time as good as the Rolex, so you're paying a little bit more for the image. If owning a Rolex, just, kind of like the prestige and that type of deal. And it's a little bit, as far as that goes. But, everything about a premium APO, and it doesn't even have to be an astrophysics, like, you could, pick up like a William Optics or like a Stellar View for like 2-3 grand, and it's almost as good as these guys, realistically. Everything about it is going to be better. So, I mean, if you have a premium mount, everything about it is nicer. The go-to is going to be nicer. The tracking is going to be better. The build quality is going to be better. I mean, the build quality, like for instance on the 130 GT, it's amazing. Like everything's just so precisely made. And then, optical quality, again, you're paying essentially for perfection. So this is kind of an extreme example. You could kind of, compare it in a more, down-to-earth example of, let's say, like a William Optics that's a 5-inch, that'll be like, let's say, like 3 grand or so, to a, modern Dob that's about $1,000, let's say in the 10-inch. That's a lot more reasonable comparison. That'd be a lot harder decision, to make, I guess. And realistically, you really want 2 scopes. You want, like some kind of wide field scope, such as this, like a 4 or 5-inch APO, and then the larger Dob, like let's say around 12 inches. That'd be more ideal. If you had to pick one, it kind of depends what you're after. I mean, if you're into astrophotography, obviously you'd want to get a refractor. If you're into planetary and double star observing, you're probably better off with the refractor, unless you know that your scene is just amazing, like mind-boggling every night. If you are, I'm really jealous. Tell me where you live. If you're, conversely into those like really small deep sky objects, the Dob's probably your better choice. I mean, it's cheaper, it's going to give you a better image. So yeah. Alright, so anyhow, if you guys have any questions, comments, or anything like that, leave them in the thing below. If you're not subscribed, please consider subscribing and hit that like button. I'll see you guys in the next video. Bye.